100 million downloads, 100,000 community variants, and 2 years of momentum. On April 2nd, 2026, Google dropped the most significant update to the Gemma family yet. The benchmark looks extraordinary. The community went to work immediately. And what they found is what this report is actually about. Welcome to the Dispatch. I am Omshri, and today I will be sharing with you my full report on Gemma 4, what Google promised and what the benchmarks showed, and what actually happens when developers like us ran it. Let's get into it. Before we talk about Gemma, let's talk about where it came from. February 2024, Gemma 1 ships, 2 sizes, 2 billion and 7 billion, text only. Google's first real move into open model territory. Modest, but a signal. June 2024, Gemma 2 scales to 9 billion and 27 billion. Better architecture, grouped query attention. Downloads start climbing. March 2025, Gemma 3. This is where things get serious. Context window jumps to 128K. Multimodality arrives. Image, video, 140 languages. By this point, 100 million total downloads, 60,000 community variants. April 2026, Gemma 4, 400 million downloads across the whole family. And a model that doesn't just iterate, it's rethink. That's the lineage. And now, let's talk about what Gemma 4 actually is. Gemma 4 ships in 4 sizes. Each one targets a completely different deployment scenario. E2B effective 2 billion. This runs on your phones, Raspberry Pis, Jetson, Orion Nano, 128K context native vision, audio and video, full on devices, near zero latency, built for battery and memory efficiency. This is the model that runs where no cloud connection exists. E4B effective 4 billion. Same hardware target as E2B. Higher reasoning capabilities, about 3x slower but meaningfully more capable. If E2B is the speed tier, E4B is the quality tier at the edge. 26B MOE, mixture of experts. This is the architecturally interesting. Total parameters 26 billion. Active parameters during interference 3.8 billion. Only the parameter that matters for a given token fire. The result, you get near 31 billion quality at the fraction of interference cost. 256K context designed for latency-sensitive production workloads. 31B dense, the flagship, every parameter active on every token. Maximum quality, 256K context, runs on a single 80GB H100 unquantized or on consumer GPUs with quantization. This is a model you can reach for when output quality is not negotiable. All 4 multimodal across text, images, video and audio. All 4s on Apache 2.0. More on this shortly. Here's the headline that matters the most. Gemma 4 31B ranks 3rd on Arena AI's text leaderboard with an ELO of 1452. The 26 billion MOE sits on 6th on 141 ELO. Both of them are outperforming models that are 20 times their size. On GPQA Diamond graduate level scientific reasoning, the 31B scores 85.7%, second best among the open models under 40 billion parameters, just behind Qwen 3.5, 27B at 85.8%. And on Arena AI, the human preference ranking, Gemma 4 consistently scores higher than automated benchmark suggests. Humans prefer how these models write, even when accuracy metrics are nearly identical. This one doesn't get enough attention, and for us, it might be the most important thing in this entire press release. Previous Gemma versions shipped under a custom Google license. The license technically allowed Google to restrict commercial use. Startup, enterprise, anyone building production products on Gemma had legal ambiguity sitting on their stack. Gemma 4 ships under Apache 2.0 licensing. That means use it for commercial without asking. Modify it, fine-tune it, ship it in your own product. No royalty, no usage-based restriction. For anyone building commercial AI products on open models, this removes a real constraint that was always in the background. The benchmark jumps get behind the headline. The license change is what unlocks the whole market. Let's put the number on screen. Coding LiveCodeBench version 6, Gemma 3 at 29.1% and Gemma 4 31B at 80%. Science GPQA Diamond 42.4% to 84.3%. Agentic tool usage LiveCodeBench, and this is the one that matters most for the real world deployment. Gemma 3 27B scores 6.6% and Gemma 4 31B scores 86.4%. Whatever change is how these models handle multi-step tool uses. It was not incremental. The agentic jump alone makes it relevant to anyone building on agentic framework. 24 hours after the release, the community went to work, and they found things Google launch post didn't mention. Problem 1. Tools weren't ready. HuggingFace transformers didn't recognize the new Gemma 4 architecture at launch. You had to install from the dev branch. PEFT, the standard fine-tuning library, couldn't handle Gemma 4 clippable linear, a new layer type in the vision encoding. It required a monkey patch to work. A third issue, a new field called mm_token_type_id is required during the training even for the text-only data, and the standard data collectors didn't produce it. All three issues were filed and response came fast, but on the launch day. Problem 2. VRAM is brutal. Developers with 40 GB of VRAM reported needing Q4KV cache quantization just to run the 31B at moderate context length. That's aggressive for hardware most teams actually have. Consumer GPUs user running the 26B or the 31B in LM Studios reported hard crashes on Mac. Problem 3. Inference speed. The community finding is consistent. For English only, speed critical deployment, Qwen 3.5 is still faster. Gemma 4 trades some throughput for multilingual quality or human preference score. That's a real trade-off, worth knowing before you choose what your stack will be. Problem 4. Safety gaps. On testing, found that 31B jailbreaks with basic system prompt manipulation. Another reported infinite loop and vision failure in Google AI Studios, non-quantized versions. Unsloth has day 1 support and fixed most of the training issues. The tooling is catching up fast. But go in with eye open. Here's the developer guide. Building a mobile app with on-device AI. E2B if latency is everything. E4B if reasoning capabilities matters more. Self-hosting for multilingual production use. 26B MOE. Best balance for quality, speed and VRAM. Available on Open Router at $0.13 per million input tokens. If you don't want to self-host, maximum quality, enterprise workload, then choose 31B dense. On a single H100 via Vertex AI or Cloud Run. Google has a fully managed path ready. Fine-tuning on limited hardware. E2B LoRA runs on a 8GB VRAM. E4B LoRA needs 10GB. The unsloth path is your clearest route right now until PEFT catches up. English only, speed critical deployment, then use Qwen 3.5. It is still the fastest choice available in the market. Gemma 4 advantage is multilingual quality, human preference scores and Apache 2.0 freedom. So, is Gemma 4 ready for production? For inference and deployment, yes, with caveats around VRAM planning. For fine-tuning, wait at least a week or two. For commercial production deployment, the Apache 2.0 license makes the first-class option along with Llama 4 and Qwen 3.5. The benchmark jumps are legitimate, especially on agentic tools used and maths. The efficiency story holds up under third-party security. And the human preference score suggests something about how this model structure outputs that raw accuracy metrics don't fully capture. Google has been competing on capability for years. With Gemma 4, they are finally competing on the openness too. Whether that's enough depends entirely on your stack, your hardware, and how much you need your model that ships globally in 140 languages on a phone. That's the Sri Sozor Dispatch report on Google's Gemma 4. If this was useful, subscribe. We cover the tools and infrastructure shaping how AI actually gets built and deployed. Link to all benchmarks, community reports, and deployment guides are in the description. I'm Om Shri. See you next time.